Hello everyone. This lesson we're going to show you the lab for three-phase balanced delta load. We still have 240 three-phase supply. We're still using 30 ohm each resistor to connect a three-phase delta connector load. So here the picture. We have a 30 ohm resistor connecting in delta, a 3 line connect to 240 volts. Because it's delta connector load, so our line voltage is 240 volts, our phase voltage will be the same 240 volts. Phase current, phase voltage divided by resistance, 240 volts divided by 30 ohm, give me 8 amps. But in delta connector load, the line current going to be √3 higher than the phase current. So √3 times 8 amps give me 13.9 amps. Power in each phase is a single phase, so just volts times amp, 240 times 8, give me 1920 watts. The total three-phase power, I use both formula to do the calculation. Phase value, line value, I have the same calculation, 5760 watts. Compare this lab to last lab, we did a three-phase Y connector load. We can see the power in the same resistance, 30 ohm. We connect them in delta. They're going to develop 3 times more power than the Y connection. Same thing, we connect three-phase load. We have to measure the resistance between any of the two terminals to confirm we connect the load properly. So I can measure the resistance between A and B, or B and C, or A and C. Because this time the load is connecting in delta, if I measure any two terminals, here's my equivalent circuit. If I just measure between A and C, there are two branches. One branch is going to be 30 ohm, another branch is going to be 230 ohm resistor in series. So I have a 30 ohm resistor on one of the branch. I have a 60 ohm resistor in another branches. If I do the calculation, it will give me 20 ohm for the total resistance between these two terminals. My resistance between A and C will be 20 ohm, same as my resistance between A and B, or between B and C. So for three-phase delta load, you have to measure 3 times for the resistance. If you both measure for this lab, you measure 20 ohm, which means your connection is right. If you measure anything is 0 ohm, you did the wrong connection, you're going to cause a short circuit, you're going to blow the fuse. Now let's look at the lab. I have a three-phase delta connector load down here. Each is 30 ohm. This meter is measuring the line voltage across my supply line. It's close to 240 volts. This meter is measuring the voltage across each phase of the resistor. It's also close to 240 volts. The slightly difference between measuring here is either the meter accuracy or the supply variation. Now I'm going to measure in the current. I'm going to first measure in the phase current. This phase current measure is 7.6 amps, close to 8 amp. What am I calculating? I'm also going to measure the line current down here, the 13.2 amps. It's very close to 13.9 amps I'm measuring. Now I'm going to show you how to measure the resistance between a delta connector load. I measure between these two terminals, I got close to 20 ohms. I measure between these two terminals, I also got close to 20 ohms. I'm measuring the last two terminals, I also got close to 20 ohms. So when I measure all 3 20 ohms, which means my delta load is connected right, and I show you the measurement on a live 3-phase delta circuit. If you have any question, you can connect us online or send us an email.